Hello, this is section 7.3, which is about solving equations by substitution method. So in this section, we'll be solving an equation, something like this, right? So when we see this, it looks complicated, right? With all of these things, with square and again another square, right? So there's a simple idea for this one here. So we can solve this, well, since there's a square here, so we can try to solve this by a quadratic process. So let's first move this to this side, and let's just make the whole thing, this equation is equals to 0. So x squared minus 5, and again square of this whole thing, plus 2 times x squared minus 5, and move this to other side, which will be plus 1, right? Now the idea is, well, if you notice, these two, x squared minus 5 and x squared minus 5 are on, well, you can see these two are same, right? So that means what we can do is, let's assume some variable, let's just say u is equals to this thing, x squared minus 5. All right, so if we replace this x squared minus 5 by u, then from here, now we will get, now instead of this, we can just write u, right? Because we just said that u is equals to this whole thing, x squared minus 5. So this is u, and still we have the square, so u is square plus 2 times this is u, right? We just said that here, u plus 1 is equals to 0. All right, so this way, this equation is much simpler to solve compared to this, right? So now after this, what we can do is, well, we know AC method, right? So we can just use that AC method. So here, 1 times 1, which is just 1, or basically just 1 times 1, right? So these two are the only factors, or just 1 is a factor of 1, right? So now if you multiply, or if you take these two pairs, then what we can do is, well, for this middle term, 2u, we can say, using 1 and 1, we can say just 1u plus 1u, or just u plus u, right? So u plus u is 2u. So basically these two are same. Now after this, split this into two parts. Now from these two, you can factor out u, and the remaining terms are u plus 1. Again, from these two, you can factor out 1. The remaining terms are again u plus 1, right? So again, we have these two common, u plus 1, u plus 1. Let's factor that out, u plus 1. And again, the remaining terms are u plus 1 is equals to 0, right? So, so this way, since, well, both of these, well, either u plus 1 is equals to 0 or u plus 1 is equals to 0, right? So basically from both you will get same thing. So let's just consider, in this case, let's just consider 1, because this r, right, because u plus 1 is equals to 0, or u plus 1 is equals to 0. So you don't have to consider same thing twice. So let's just erase this, and let's just consider this, which is u is equals to -1, right? All right, so since our original equation is in terms of x, but we changed our this thing to u, so after this we need to write our final answer in terms of x. All right, so to do that, as we said that here, up here, u is x squared minus 5. So let's replace this back to x. So x squared minus 5 is u, right, is equals to -1. All right, now to find the value of x, let's move this to other side. X squared is equals to -1 plus 5. X squared is equals to +4. All right, so now if you notice, this is, well, this is basically a square root property. You can directly use that, right? So if you take the square root on both sides, on this side we'll just get x Now this side will get square root of 4. But the thing is, whenever you're taking square root, all right, whenever you're taking square root, not square, whenever you're taking square root on both sides, you need to consider plus and minus case. So this way we will get x is equals to plus minus 2. So x is either positive 2 or negative 2, right? So this is the final answer. So this is how you can solve a complex equation like this. So whenever you see these two same, you can solve this thing by using this process. All right, that's it. Thank you.